All right, now we're going to go back and use what we used in our last unit, our right triangle trig. We're going to kind of go back and use that a little bit in this next part. So we're going to say theta here is still going to be an angle. Here's our theta right there. It's an angle in what we call standard form. Remember, it starts on the x-axis and it goes over to our terminal side right there. And P, our point right here, which is an x-coordinate and a y-coordinate, is a point on the terminal side of theta. And the distance from P to the origin, they called this R right here. So they called that distance R, or radius right there. We'll tell you why it's radius in the next unit. Can be found using this formula. Now, it really is the Pythagorean theorem. Remember, if this point right here is our x, y value, that just means that this distance right there, that's whatever x was. This distance right there is whatever y was. Okay, so it is really, if we did our Pythagorean theorem, we could just say it was a squared, which in this case is x squared, plus b squared, which was y squared. I'm going to erase that so you can see that that says y and that says x, is equal to your radius squared, or your hypotenuse squared, which is, in this case, is your r squared. All right, so that's how you find this. Now, notice as well, what they're always going to do here is they're going to take this reference angle. Now, even if this is an angle that is bigger than 90 degrees, notice how that theta is in quadrant 2, so it's got to be greater than 90 degrees. To find these values, though, they're always going to use the reference angle. So remember, that was the angle that goes from our terminal side to the x-axis. So they're going to use theta inside the triangle right there. All right, so remember, if you were to do our, I'm going to write this up here again, the SOHCAHTOA is coming back to us again. If you were to look at that right there, if we do our sine right here, which was the opposite, here's my opposite over the hypotenuse, then I just have y divided by r for my sine. Okay, my cosine, here's my adjacent side. So my cosine was the adjacent over the hypotenuse, or x over r. And then the tangent of theta is my opposite over the adjacent, or y over x. Y divided by x right here. Okay, and then I'm just going to go ahead and flip all of these. The cosecant is just r over y. Secant is just r over x. And the cotangent is x over y. Again, remember that these are just reciprocals of their other function above them. Okay, so we just flip them right there. All right, so basically, if we just have the three sides of our triangle, they'll give you two of them. We find the other ones and just write them down. It's pretty simple, pretty basic. We could do it. Again, this is our x and this is our y. So when we're looking at this one, we're going to go over 5 and down 2. Okay, so that is a point on what they call the terminal side of my angle. So if I were, let's draw the terminal side right there from the origin. And right there, actually, sorry guys, I'm going to erase that and do it. My calibration's not very good, so I'm going to go a little bit farther so I can kind of see right here. And then to get my reference angle, remember it goes from, let's do green, it goes from the x-axis to that terminal side. So there's my theta right there. Okay, so when I'm drawing this, I'm going to go ahead and mark something in here. I know I went over 5. So this 5 right there is that side. I went down 2. I am going to use the -2 for all of my values right there. And then I've got to find my radius, or my r, over here. So we're going to do that next. But before we do that, let's go ahead and label the triangle. This was our theta right here in this corner. So this side is opposite. This side would be my adjacent. And then my hypotenuse is the one that's missing right there. So again, we can just use our Pythagorean theorem up here. X squared plus y squared equals r squared to find this missing side. So let's go ahead and do that. We've got our 5 squared. That was our x, plus -2 squared. That equals r squared. Well, 5 squared is 25. Negative 2 squared, be sure to put parentheses if you square it. It is going to be a positive number. Negative 2 times negative 2 is positive 4. That's equal to r squared. 25 plus 4 is 29. That's equal to r squared. And then we can just take the square root of both sides to find r. So r is going to be equal to the square root of 29. Square root of 29 right there. All right, so when we go through to plug all this stuff in, basically you can look up here. Well, let's do it in green. You can look up here and just say y and r, or you could look at your picture. I kind of look at my picture. So the sign is going to be your opposite over your hypotenuse. So here's my opposite over my hypotenuse. I've got negative 2 over the square root of 29. However, you guys are all pros at this from last year. This was a no-no, or last unit and last year. You're going to multiply by the square root of 29, or square root of 29. So this is going to be negative. Don't forget the negative. 2 square roots of 29 all over 29. We're going to circle that as an answer. Let's do the cosecant while we're right here. Remember, cosecant is just going to be the reciprocal, so this one's actually easier. It's the square root of 29 over negative 2. And again, the negative could be at the top or the bottom, doesn't matter. But we don't have to worry about rationalizing that one because my radical's in the top, not the bottom. We only have to do this. We just don't want to make sure that there's not a radical in the denominator. All right, let's look at the cosine right here. So the cosine of theta is the adjacent over the hypotenuse. So it's going to be 5 over the square root of 29. Again, rationalize that denominator. So that's going to turn into 5 square roots of 29 over 29. The secant's easier. We're just going to flip those. So the square root of 29 is on the top over 5. And then our tangent and cotangent are going to be the easiest ones on these because they're going to be whole numbers. The tangent, notice up here, remember, is just y over x, or your opposite over your adjacent. So negative 2 over 5, which means the cotangent is 5 over negative 2. And you have found all 6 trig values when you're given a point that's on the terminal side of the angle.